Elon Musk is deeply committed to guiding humanity to Mars and further afield. He is completely committed to making long-distance space travel a reality and is making every effort to do it. However, achieving this goal will necessitate much research and hard work. Welcome back to another exciting video. Today's video is about Elon Musk just revealed insane new SpaceX rocket engine. Before we start the video, please like, subscribe, and press the bell icon. He recently announced a stunning and game-changing rocket engine that can exceed all expectations. What distinguishes this new engine? And how does it differ from its counterparts? Let us investigate. Elon Musk has a strong interest in space exploration, notably the Mars expedition. The road to Mars is definitely difficult and time-consuming, but Musk's drive knows no limitations. To address this challenge, he created the magnetic fusion plasma drive, an astonishing solution. This groundbreaking rocket engine has the potential to take us not only to Mars, but much further afield. Musk's bold goal is to get astronauts walking on Mars by 2029, and this fantastic engine is a critical step toward that goal. Musk's ultimate goal is to build a self-sustaining city on Mars that can house 1 million people. Humanity is becoming a multi-planet species. This is more than simply survival insurance. It's an opportunity to build something amazing and push the boundaries of what's possible. While the initial timescale for people reaching Mars was projected to be in the 2020s, Musk's new Twitter post hints that the actuality of astronauts landing on Mars may be just around the corner around the year 2029. That's getting closer than we thought. There are, however, obstacles to overcome, from traversing the perilous Martian landscape to constructing long-term living circumstances. This is where Starship enters the picture. Texas is currently developing this fully reusable rocket. This is special since it has the capability of transporting over 100 tons of cargo or 100 passengers to space at the same time. By refueling using Martian resources, astronauts may fly even further, establishing refueling stations on distant planets and extending the limits of human exploration. Isn't it unbelievable? That's exactly what's going to happen soon. How long does it take to get to Mars? It all relies on a variety of things. It would take around 40 years if you drove at an average speed of 161 kilometers per hour, 100 miles per hour. This means you will not be returning to Earth. Isn't our lifetime working against us? Keep in mind that the distance between Earth and Mars varies due to their distinct sun orbits. The distance between Earth and the Moon fluctuates according to their orbits around the Sun. They are around 56 million kilometers apart at their closest point, known as opposition. This occurs every 2 years and is excellent for launching missions to the Moon. Several missions have successfully flown to the Moon, each with a different time, such as the Viking 1 mission, which took 10 months to reach Mars after being launched in 1976. In 2003 and 2004, the Spirit and Opportunity rovers arrived in 6 months. The Curiosity rover arrived on Mars 8 months after its launch in 2011. The most recent mission, the Perseverance rover, arrived in 2021 in 6.5 months. For crewed missions to Mars, different space agencies have distinct ambitions. SpaceX wants to cut the journey duration to 6 months, while NASA wants to take 9 months. The chosen mode of propulsion has a significant impact on the trip's duration. Similarly, the length of a trip to the Moon is determined by the mission and technique chosen. In 2008, Richard Branson explored the prospect of establishing space hotels for extended stops in Earth orbit that may serve as launching points for brief Moon tourist flights. The Apollo missions, particularly Apollo 11, which landed the first humans on the Moon, drew a lot of interest in the media. The astronauts were launched into orbit by a Saturn V rocket and arrived at the Moon after 51 hours and 49 minutes. The mission lasted around 109 hours and 42 minutes. Travel periods to the Moon vary depending on mission and approach, ranging from a few days to several months. The Chinese Chang'e missions took 5 days, whereas the New Horizons mission, which went past the Moon on its way to Pluto, arrived at the Moon in just 8 hours and 35 minutes. There are several fascinating propulsion ideas out there right now that could propel us beyond the stars. We're discussing the magnetic fusion plasma drive. This is an incredible technology that blends fusion and ionic processes. Professor Florian Nuckert of Leiden University believes this engine has the potential to transform space travel. Consider lunar, Mars, distant stars, and even interstellar things traveling through our solar system. We've seen these in movies before, but we're talking about real life here. Wait, these are actual plans and concepts that are being considered. The potential for scientific research is immense. However, more improved propulsion technologies are required to make these large expeditions a reality. While amazing, chemical propulsion has limitations. We need technology that can go above and beyond in terms of endurance, energy efficiency, and thrust. This is where the magnetic fusion plasma drive enters the picture. Florian Nuckert, the brains behind this idea, sees a propulsion system that consumes fuel effectively and has a high energy density. With fusion reactions and extremely high specific impulse and thrust, this drive has the potential to revolutionize the game. It's like going from a horse-drawn carriage to a supersonic spaceship. But remember the difficulties that come with such complex propulsion technologies. Handling and releasing nuclear materials, as well as technical issues and even safety concerns, must all be handled. It's a difficult puzzle that scientists and engineers are working hard to solve. Consider the possibilities. Faster flights to Mars, longer missions to the furthest limits of our solar system, and possibly even intergalactic travel are all possibilities. Space exploration's boundaries are being pushed further than ever before. Florian Nuckert's magnetic fusion plasma engine is an exciting proposal for space exploration propulsion. This system's principal energy source is controlled nuclear fusion reactions, which can be used to generate thrust as well as power. Particles are expelled at high velocities by harnessing the enormous energy released by fusion reactions, which commonly involve isotopes of hydrogen or helium, complying with Newton's third law and providing propulsion. Magnetic fields are used to contain and control the plasma produced by fusion processes. This allows for controlled energy release and directionality. Nuckert's concept also includes the option of transferring some of the fusion energy into electricity to power onboard systems and even the reaction control system. This concept is based on well-studied deuterium-tritium fusion processes, which provide a familiar framework for explaining the basic physics of the magnetic fusion plasma drive, or MFPD. When compared to alternate ideas, these reactions have higher cross-sections and lower ignition temperatures, giving them a good starting point for analyzing the efficacy of this hypothetical power system. However, it is critical to recognize that the stability of fusion events in space represents a substantial difficulty. While significant progress has been made on Earth in magnetic confinement, fusion, and inertial confinement fusion, achieving stable fusion reactions in space remains a daunting task. Researchers are working hard to overcome this obstacle. But wait, there's more. SpaceX just made a significant advance by completing a critical test of its Raptor vacuum engine. This engine is specifically engineered to withstand the intense cold of space, which is a challenging task. This test is an important step forward in SpaceX's ambitious ambition to land the Artemis 3 crew on the Moon using their magnificent Starship rocket. The business hopes to complete this extraordinary feat by 2025 or 2026, and the Raptor vacuum engine will be critical in making it happen. Thanks for watching the video. If you enjoyed it, please like, share, and subscribe to our channel for more exciting content.